This is 5.1. First, I'll do a quick recap. So integration is just the opposite of deriving. When you're deriving, you go from y to y prime, yeah? But for integration, you're going from y prime back to y, okay? But whenever you have to integrate, for example, they want you to integrate 3x squared, yeah? To integrate aslan, you're going to add 1 to the exponent, so you keep everything the same, but you add 1 to the exponent, then you divide by your new exponent. So we're going to divide by 3 here, so that means this is x cubed, okay? But another thing with integration is that you always have to end it with plus c, okay? Because when you're deriving something, for example, you're deriving 3x plus 2, this is your normal function, okay? When you derive it, you would get 3. Okay, so we did this term, we got it, but there's a term here that once it goes, like here it gets cancelled out, here it goes to 0, gets cancelled out, we'll never be able to get it back, so we just write it as c, okay? But that's a quick recap for basic integration. Another thing is that when you're integrating, I will say simplifying as much as possible will help you out a lot. It's gonna save you time, it's gonna save you a lot of thinking. Just simplify as much as you can, and it's gonna help you big time. Now this type of integration is the indefinite integration. It's when you have an expression here, so you have 3x for example, and it's just they want the integration of this. Another type is when you have 3x for example, and they want you to do it from 0 to 2. So when you have two numbers here, this is definite integration. But I don't think they're gonna bring definite integration into this section. I don't think it's coming in the exam, but this one, if it comes, I'll explain it, but I don't think it will. So here's number 1. So this is another thing I forgot to mention. When you have integration and the inside is like, it's big, it's complicated or whatever, you wanna look at each part inside. So the 3 here, this is fine, there's nothing wrong with this, okay? And then there's second part here, this is to the power of 4. Now to do anything to the power of 4, you have to do the binomial, yani you do x cubed plus 5x plus the n choose r things like this. It's gonna keep taking a long time, so instead what we do is we replace this complex part with u, okay? But for now I'll keep looking at the rest of the expression. Here we come back, this part is fine, it's not bad, okay? So I'll rewrite this, yeah, as the integration of 3 into, we'll replace this part to be u to the power of 4 times, the last part stays as it is, 10x squared plus 25, okay? This is gonna simplify things when you have a long section here that's gonna take you time. Usually we do it when there's a big power, like here to the power of 4, so we just replace it with u. Now when you're doing the complex integration, you're always gonna want to write down on your side. So here you're gonna write down the u, which is x cubed plus 5x, right? Because that's what we replaced it by here. And you're also going to want to write your dx equals to. So for dx, you could memorize this. It's always going to be equal to du over u prime, okay? So du, we just keep it the same as it is, du, and u prime, we derive the top here, so it's 3x squared plus 5. This is our dx, okay? So I'll bring this expression, I'll rewrite it over here. It's the integration of 3u to the power of 4 times 15x squared plus 25, okay? This is all dx, okay? And we have u is this, x cubed plus 5x, and dx is du over 3x squared plus 5. I just rewrote everything so I have more space to explain. Now here they're telling you applying the substitution method gives you this. Now to find which step they're in, you could just look at the ending here. Here it ends with du. In our expression we have a dx, okay? So that means we want to substitute dx. So we're gonna keep this 3 to the power 4 times 15x squared plus 25. This is in brackets because it's one term, and then times du over 3x squared plus 5. Okay, and if you divide this part by this part, it cancels out, gives you 5. So that means this is equals to 3u to the power 4 times 5 times du. Okay, this is all integrated. So that means it's the integration of 15u to the power 4 du. Now this part here, you don't actually need to do this, but I'm just telling you how to do it in case they ask you in the exam. For example, they're telling you, show me the steps you do to get to this part, okay? But in this question, they're not actually asking for it. I'm just doing it in case it comes. Now what they're asking for is which of the following is true. Select all that apply. The first option we look. They're saying du is equals to 3x squared plus 5 times dx. Here we have the formula for dx and du. We'll reshape this so that we have du on one side, everything else on the other. So we'll bring this part, bring it to the other side, so that means it's 3x squared plus 5 all times dx. So this is the equation for du that we got. And see, does it match it? Yes, it does, so it's a correct option. This next option, they're asking for u. So let's look at our u. We got our u to be x cubed plus 5x. So we'll look, does it match it? No, it doesn't. It's a different equation, so we don't choose it. This one, it does match it. It's the same, x cubed plus 5x, so we choose it. And the rest are just the same thing, we don't choose any. Part B, they're saying using part A to solve for the integration, you get this expression. Now to do this part, we're going to use what they gave us here. Okay, we got the same thing, but you don't need to calculate it again. You can just use the expression they gave you, which is I equals to the integration of 15 u to the power 4 du. They want us to integrate this. Okay, so we're going to integrate. We're going to keep the 15 as it is, and the u, we add 1 to the exponent, so it becomes to the power of 5, and divide by this new exponent. Divide by 5, so you get 3u to the power of 5 plus c. Okay, this is the integrated form. So 3u to the power of 5 plus c. And now since we finished everything, we finished our integration, we could go ahead and substitute our u back in. So that means we're going to replace it with the value we had for it before, which is x cubed plus 5x, this all to the power of 5, and keep the plus c as it is. So this is our final integrated form. We just give them the answer, we fill in the parts that they want. Thus. Number 2. This question is showing what I mean by simplifying. So if you come look here, this, okay, this 2 is applying for both terms. It applies for here and applies for here. What I mean is that this is the same as saying 300 over 2x squared plus 24 over 2x on this dx. So that means this is the same as saying 150 x squared plus 12x dx. Okay, this is a lot easier to integrate now that we got it into this form. Okay, so we'll start our integration. We'll keep 150 as it is. The x squared will become x cubed. We divide by our new exponent, and same thing for the 12, plus 12 into x squared divided by 2. Okay, this after you simplify, 150 divided by 3 is 50, so it's 50x cubed plus 6x squared plus c. And this is our final answer. Number 3, part A. They're just asking for the integration of this, so I'll go ahead, I'll just write it up here more clear. Minus 8x. Okay, so we'll go ahead and integrate adi. Minus 8 we keep the same, becomes x squared, so we divide by 2. So that means it's minus 8 divided by 2 is minus 4x squared plus c. This is your answer, minus 4x squared plus c, minus 4x squared plus c. Part B, they're saying let m be a constant, thus this part is what? The integration of this is what? Okay, when you have anything as a constant, and you have integration of 3x, for example, this isn't related, but it's explaining. This is the same as saying 3 integration of x. Okay, you can take out the constants and just multiply by them later. Okay, so that's what we're gonna do for this question. I will rewrite it here. It's the integration of 12 into m minus 2 cubed x cubed dx. I'll take out this part because it's more complex. I'll take it out. So it's m minus 2 cubed times the integration of 12x cubed dx. So that means this simplifies into m minus 2 cubed, and then we can integrate this part normally. So it's 12x to the power of 4 divided by 4 plus c. So in the end you get m minus 2 cubed times 3x to the power of 4 plus c. Okay, now here, but that's what's this? Here, this is our final answer. They just put this between the 3 and the x, but it's the same number in the end. This, you just give them 3, 3, and the powers are 4. Now part C. Part C, they're saying that y equals to 2x squared, and they want us to integrate this. So the integration of 3 into y cubed over x, this all dx. Okay, they told us that the y is 2x squared, so we'll substitute. It's 3 into 2x squared to the power of 3 over x, all dx. So that it simplifies into, I'll raise this to the power of 3, so 2x squared to the power of 3 is what? It's integration 3 into 2 to the power of 3 is 8, x squared to the power of 3, 2 times 3, so x to the power of 6, over x dx. Now we'll distribute the 3, so 3 times 8 is 24, x6 over x is all integration. Okay, so that means in the end, x to the power of 6 and x cancel out, so this goes down, this becomes 5, so it's the integration of 24 x to the power of 5 dx. Now we can integrate normally. So this is just 24 times x to the power of 6 over 6, and 24 divided by 6, you get 4x to the power of 6 plus c. And that's your final answer. Number 4. This is going to be similar to what we saw before. What we've seen before is that when you have the equation for displacement, we'll call it s, if you derive once, okay, so it becomes ds over dx or whatever. Okay, you derive once, it gives you the velocity. You derive the velocity once, it gives you the acceleration. Okay, so here it's going to be the opposite. They will give you the acceleration and they want the velocity, or they want the displacement. Okay, so instead of deriving to go from here to here, we'll just integrate. So integrate and integrate. Okay, yeah, let's start. The acceleration, so they gave us acceleration of a particle moving in a straight line at time t is given by a equals to 12t minus 2. Okay, they're asking for part A. If at t equals to 0 the velocity equals to 3, then at any time the equation for v is what? So they want us to integrate this to get the equation for velocity. So we'll integrate. So the velocity is going to be equal. I'll do it in a different color so we don't mix it up later. So the velocity is equals to the integration of 12t minus 2. Yani it's 12 into t squared over 2 minus 2t. Okay, integration of any constant, you just add the variable beside it. So this is 6t squared minus 2t plus c. Okay, now we can't give them the equation and just write c. We always have to fill it in with a value. Okay, and to find this value, they need to give us some information about this equation. So they're telling us at time is 0, so when this t is 0, the velocity is equals to 3. Okay, so that means 3 is equals to 6 into 0 squared minus 2 into 0 plus c. Okay, this cancels 0, this cancels 0, so that you get 3 equals to c, or c equals to 0. So now we take this, put it into our equation. Okay, so our final equation would be velocity is 6t squared minus 2t. We substitute the c, so we get plus 3. This is your first answer. Now for part B, I'll do it in red. They're asking for the displacement equation. We have our, where is this? We now have our velocity equation. Okay, so we need to integrate that to get our displacement. So we'll integrate the 6t squared, what was it? Minus 2t plus 3, minus 2t plus 3 dt. Integrate this, we'll get it to be 6 into t cubed over 3 minus 2t squared over 2 plus 3t plus c. So this in the end is equals to, I'll write it here. So this is 2t cubed minus t squared plus 3t plus c. Okay, now again we can't give them with c, so we need to look at what information we know. At time is 0, the displacement is 1. So that means this whole thing is 1 at time 0, at 2 into 0 cubed minus 0 squared plus 3 into 0 plus c. This all cancels out to be 0, 0, 0. So that means c equals to 1. So we'll rewrite our final equation. Instead of c, it's just 1. And this is your displacement. Give them this is the equation they want. Number 5, this is also integration, just basic integration. You just do it as it is. This is, they're asking for the integration of 49x squared the radical x dx. Now this is the same as saying 49x squared times x to the 1 over 2. صح, radical يعني power of 1 over 2. This dx. يعني this is also the same as saying 49 into x2 plus 1 over 2. صح, when you have two bases you could add their powers. So 2 plus 1 over 2 is 5 over 2 dx. Okay, so now we'll integrate this. It's 49, keep it as it is, times x. 5 over 2 plus 1 is 7 over 2. And then we divide by 7 over 2. Now when you're dividing by a fraction, it's the same thing as multiplying by its opposite. Yani instead of dividing by 7 over 2, we can multiply by 2 over 7. Okay, I'll get rid of this part. So 49 times 2 over 7, you get 14. So you get 14 into x to the power of 7 over 2 plus c. Okay, here they're asking for this part simplified. If you needed to simplify it, you could just say it's 14 times. Now the 7 over 2, you could put it on your calculator and make it give you an improper fraction. It would give you 3 into 1 over 2. Okay, so that means we have x cubed, and then we still have x to the power of 1 over 2. Okay, plus c. So this is the same as saying 14x cubed radical x plus c. And this is your final answer. Number 6, part A. This part you might be thinking we need to substitute with u and do the dx, du, all this. But I'm gonna give you a tip. Generally, we don't do this unless there's a big power. So unless there's power of 4, power of 2, power of 7, a big power, it's going to be just normal expansion. Okay, we're just going to derive normally. So this I'll expand here. So it's the same as saying integration. X squared times 8x is 8x cubed. And then we'll do 2x plus 16x squared plus 24x. Now minus 16x squared minus 32x and minus 48. Okay, all this dx. So it's a bit longer, but still it's easier than using a u and getting mixed up. Okay, so we could simplify this. Plus 16 cancels out with minus 16, and plus 24 and minus 32 just become minus 8. So I'll rewrite everything here. So it's just integration of 8x cubed minus 8x minus 48, and this dx. So we could integrate now. 8x to the power 4 divided by 4 minus 8x squared divided by 2 minus 48x plus c. So we simplify, you get 2x to the power of 4 minus 4x squared minus 48x plus c. This is your final answer. For part B, it's the same thing. We're just going to simplify as much as possible before we get to the integrating. So here, this is the same as saying 9x to the power of 5 over x cubed plus 6x cubed over x cubed dx. So that means this is the same. X to the power of 5 divided by x to the power of 3. It's 5 minus 3, so it's 2. So it's 9x to the power of 2 plus x3 and x3 cancel out, so it's plus 6. There's dx, so you can now integrate. So this is 9x cubed divided by 3 plus 6x. Okay, simplify this, you get 3x cubed plus 6x plus c. 3x cubed plus 6x plus c, and that's your final answer. Number 7. Here, this is in the AMS quiz, I believe, but here they're asking for when after you integrate, when you substitute 0 minus when you substitute 1. Okay, so for this we're going to integrate normally, but here we have a complex part. Okay, we have a power here, so we're just gonna replace it with u. So it's 40x over u dx. Now I'll write up here that our u is 2x squared minus 1, because that's what we replaced, and our dx is du over u prime. So it's du over 4x, yeah, just 4x. When you derive this, when you derive u, you get 4x. Okay, so now we'll substitute that into our equation. It's 40x over u. I forgot this is u squared, okay, because we have to the power of 2. So it's u squared. Now instead of writing times dx, we're going to multiply by what we got for it, so this part. So times du over 4x. Now one thing I will say, when you're doing this complex integration, your x should always cancel out. If it doesn't cancel out, that means you've done something wrong. And in the end, you shouldn't have an x term. Okay? And that's what happened here. We got the x cancels out. So I'll rewrite this, and the 40 divided by 4 is 10. So that means it's the integration of 10. And then this u squared, I'll just bring it up. So it's u to the minus 2 into du. Okay? Now we can integrate. So this is the same as saying 2n into u. Minus 2 plus 1 is minus 1. Then we divide by minus 1. Okay? Plus c. So this is the same as saying minus 10 over u plus c. Right? Because I brought the u back down. Now this is what we got for w of x. They're asking for w of 0 minus w of 1. Okay, I'll do w of 0 in blue, so we don't get lost in the middle. So here w of 0 and w of 1. W of 0, let's see, here w of 0 equals to minus 10 over 0. Hold on, my bad. When we finished this part here, when we got to here, we need to replace the u back with what we replaced it with in the beginning. So this is minus 10 over, here we said it's 2x squared minus 1. We'll bring it back and put it in, over 2x squared minus 1 plus c. So this is our final equation. Okay, it's this here. So we'll substitute into that. Okay, so into 2 0 squared minus 1 plus c, and for the other one, do it in here yellow, w into 1 equals to minus 10 into 2 1 squared minus 1 plus c. Okay, they want us to subtract these two. So when you subtract, it's gonna be minus, it's gonna be minus 10 into 2 0 squared minus 1, this minus 10 into 2 1 squared minus 1. I can see here that I'm not writing the c's because the c's actually cancel out when you're subtracting. So it's gonna be, because you have here plus c and you have here plus c, and this minus makes this negative, so plus c minus c, they cancel out. So here I didn't write the c, I just skipped it. Okay, so you put this onto your calculator and you should get 20, and that's our final answer, is 20. Number 8, part A, this is integration. So we'll start, I'll write it again here. They're asking for the integration of x over radical 5x squared plus 1 dx. Okay, this is the same as saying x over 5x squared plus 1 to the power of 1 over 2. Okay, here I will use a u. I'll substitute this part with u. Okay, so our u is going to be equals to 5x squared plus 1, and our dx will be du over u prime, so that means over 10x. Okay, we'll substitute all these, so it's x over u to the 1 over 2 times dx is du over 10x. Okay, here our x cancels out, so this is equals to 1 over 10u to the 1 over 2 du. Okay, this is integration. So now we got to here, we got to this part here. So we're gonna have to integrate this, so that means we need to bring the u to the top. So that means it's u to the minus 1 over 2, right? It's the integration over 10 du. Okay. So now we could integrate this. It's going to be 1 over 10 times u minus 1 over 2 plus 1 is 1 over 2. Okay, and we're going to divide by our new fraction. Okay, this plus c. So this dividing by 1 over 2 is the same as multiplying by 2. So it's 1 over 10 times u to the 1 over 2 times 2 plus c. So it's the same as 1 over 5 u to the power of 1 over 2 plus c. Okay, and this here is the same thing. So I'll just put the u up here. We'll just move it up here, and plus c put it here. Okay, we'll substitute our u with what we had for it in the beginning, which was 5x squared plus 1. So we have 5x squared plus 1, all of this to the power of half, yani I'll put it under a radical, over 5 plus c. This is the final answer for this part, 5x squared plus 1 over c. That's how you get that. Now part B, this is also integration with using a u. So for this, we'll do this part as u. Okay, so u equals to 8x cubed minus 3, and dx is du over u prime is 8 times 3 is 24x squared. Okay, so I'll rewrite it here. It's 4x squared into u to the power of 7. We don't need the brackets, I'll remove them. So it's just this. Okay, this times dx, we need to change the dx, so we'll multiply by du over 24x squared. Yeah, instead of saying dx, we just wrote this. Okay, here our x cancels out, so that means so far we're correct. Okay, so this is equals to, and 4 over 24 is just 1 over 6, so it's 1 over 6 u to the power of 7 du. This is integration still. And now we could integrate this. So this is 1 over 6 times u to the power of 8 divided by 8. Okay, so we could just put the u over 8. This is the same thing. Okay, plus c. So that means 1 over 6 times 1 over 8. So because it's 6 times 8 is 48. So it's u to the power of 8 over 48 plus c. Now we'll replace the u with the value we had before, which was 8x cubed minus 3. So it's 8x cubed minus 3 all to the power of 8 over 48 plus c. This is the final answer. This here, number 9, is more simple integration. So integration of x to the power of 6 is just going to be x to the power of 6 dx. So here it's just going to be x to the power of 7 divided by 7 plus c. That's simple, easy. Part B, also it's easy. I'll bring the x up, so this is the same as saying x to the minus 3 dx. So that means this is x minus 3 plus 1 is minus 2 divided by minus 2 plus c. So to simplify this, it's minus 1 over 2. X to the minus 2 will bring it down, so it's x squared plus c. This is your answer. Go ahead, put that here. Part C, the integration of this is the same as saying the integration of x to the 1 over 2 times x to the 2 over 3. This dx. So 1 over 2 plus 2 over 3 is 7 over 6. So that means this is the same as saying integration of 7 over 6 dx. So that means this is 7 over 6 plus 1 is 13 over 6. Okay, and we divide by this new fraction. So we divide by 13 over 6. Or we could multiply by its opposite. So we'll just multiply by 6 over 13. Okay, this plus c. So that means we get 6 over 13. And then x to the power of 13 over 6, right on the side. Now for 13 over 6, you just put it on your calculator and make it a mixed fraction. It's the same as 2 into 1 over 6. So that means we have an x squared, and we also have an x to the power of 1 over 6 plus c. Simplify some more. 6 over 13, x squared, x to the 1 over 6, يعني it's the 6th root of x. The numerator goes inside the radical and the denominator is outside. So this plus c, this is your final answer. Number 10 here, it's the last bit of integration. So this is more complex integration, it's more practice with you. I'll write it up here. It's into 2, 4x minus 1 to the power of 6. 4x minus 1 to the power of 6. We'll replace with u. So we'll do it's 2 into u to the power of 6. So that means our u is 4x plus 1. And our dx, here it's dx. Dx is du over 4. Okay. So we'll substitute our dx. So it's 2 times u to the power of 6 times du over 4. 2 and 4 give you 1 over 2, so it's 1 over 2 u to the power of 6 times du. And now we could integrate this. So it's 1 over 2 times e to the power of 6, to the power of 7, sorry, and you divide by 7. So just put this over 7 and multiply these two. So 1 over 2 times 1 over 7, it's 1 over 14, u to the power of 7 plus c. Okay. Yeah, and here it's correct. You simplify, you replace your u again with 4x minus 1. So here's 1 over 14 into 4x minus 1 to the power of 7 plus c. And that's the answer they have here. That's your final answer. Part B, this is pretty much the same thing. So radical 1 over u to the power of 6 times dx. Okay, our u is 4x plus 3, because that's what we replaced here, and our dx is du over u prime is 4. So we'll replace the dx, it's integration of 1 over u to the power of 6 times du over 4. Okay, and to integrate I need to bring the u up, so that's what I will do. It's u to the minus 6 over 4 du. So now we can start integrating. This is the same as saying 1 over 4 times u to the minus 6 becomes u to the minus 5, because we're adding 1, and this, and we're dividing by our new exponent, which is minus 5. Okay, so all this plus c, 4 times minus 5 gives you minus 20, so it's minus 20 into, I'll bring the u back down, it's u to the power of 5 plus c. Okay, this is your final answer. They just substituted the u again. Oh, but that's 5.1.